Scene script. Have you ever wondered what would happen if Earth didn't have a moon? A question that might seem purely hypothetical, yet its answer reveals an astonishing reality about our world's complex relationship with its only natural satellite. Our understanding of the moon's origin is still a subject of ongoing research. The most widely accepted theory is the giant impact hypothesis. This postulates that about 4.5 billion years ago, a Mars-sized body named Theia collided with the young Earth, resulting in a debris cloud that eventually coalesced to form our moon. The moon's influence on Earth goes far beyond merely lighting up our night sky. It's a key player in Earth's evolution, shaping the planet we know today in ways more profound than you might imagine. Consider, for instance, the role of the moon in Earth's rotation. Our planet spins on its axis, completing one rotation every 24 hours, a phenomenon that gives us our day and night. But without the moon's gravitational pull, Earth's rotational speed would increase, leading to drastically shorter days, possibly only 6 hours long. Then, there are the tides, the rhythmic rise and fall of sea levels. These are primarily caused by the gravitational interaction between Earth and its moon. The moon's gravitational pull tugs at Earth's waters, causing high and low tides. Without the moon, our planet would experience much weaker tides, significantly altering coastal ecosystems. Moreover, the moon's existence has had a profound influence on life itself. From ancient times, various species, including humans, have used the moon for navigation and timekeeping. The moon's phases have served as a natural calendar, influencing agricultural practices and cultural traditions. Now, imagine a world where all these moon-induced phenomena cease to exist. A world with drastically shorter days, weaker tides, and a life that had to evolve without the guidance of the moon. It's a thought-provoking scenario, isn't it? But this is just the beginning. In the following scenes, we will delve deeper into the consequences of a moonless Earth. Without the moon, Earth's tidal patterns would be drastically different. Now that might seem a simple enough statement, but let's delve deeper into the science of it. You see, the moon is a key player in creating the tides we're all familiar with. It's a gravitational dance that's been going on for billions of years. As the moon orbits Earth, it exerts a gravitational pull on our planet. This pull is strongest on the side of Earth facing the moon, causing the ocean to bulge outwards. As Earth spins on its axis, different parts of the world pass through this bulge, leading to high tides. Conversely, on the sides perpendicular to the moon, the ocean is pulled less, causing low tides. It's a rhythmic ebb and flow that our planet has grown accustomed to. But imagine, if you will, a world without our lunar companion. Without the moon's gravitational influence, our tides would be significantly smaller. They'd be primarily influenced by the sun, which, despite its size, is so far away that its gravitational effect on our oceans is only about 46% that of the moon. This change in tidal patterns would have a knock-on effect on ocean circulation. The currents that transport warm and cold water around the globe, think the Gulf Stream or the Antarctic Circumpolar Current, could potentially be altered. These currents play a crucial role in regulating our planet's climate and supporting a myriad of marine life. If these currents were to change, it could lead to drastic shifts in climate and threaten the survival of many marine species. We could see species migration, population decline, even extinction in some cases. Furthermore, it could alter weather patterns, potentially leading to more extreme weather events. So, while a moonless Earth might mean less dramatic tides and calmer oceans, the ripple effects could be far-reaching. The moon, it turns out, plays a more vital role in our lives than just lighting up the night sky. Our oceans would be much calmer, but at what cost? How about a much shorter day and, consequently, a faster-paced life? The moon, our celestial companion, plays a pivotal role in the way our planet functions, and one of its most significant influences is on the Earth's rotation. The moon's gravitational pull acts as a kind of cosmic brake, slowing down the Earth's spin on its axis. Imagine having to cram 24 hours worth of activities into a day that lasts only 6 to 8 hours. That's what life could be like without the moon's gravity to keep our planet's rotation in check. Our Earth is like a spinning top. Without the moon's stabilizing influence, it would spin much faster. As a result, our days and nights would be considerably shorter. Imagine the sun rising and setting 3 to 4 times in what we now consider a single day. This increased spin speed would have far-reaching impacts. For starters, our concept of time itself would be drastically altered. The 24-hour day we're so accustomed to would become a thing of the past. We would have to adapt to a new rhythm, a new pace of life. Furthermore, this rapid rotation would also have significant implications for our planet's climate and weather patterns. The faster spin could lead to stronger winds and more extreme weather events, changing the face of our planet as we know it. The moon's gravity, therefore, is not just a force that pulls the tides. It's a crucial element in the delicate balance that allows life as we know it to exist on Earth. It's the silent partner that keeps our world spinning at just the right pace, allowing us to live our lives in a rhythm that feels natural and right. So the next time you gaze up at the night sky and see the moon shining down, take a moment to appreciate its silent but significant role in our lives. A day might just last 6 to 8 hours, significantly altering our concept of time. Ever thought of a wobbly Earth? Now that's a question that probably doesn't cross your mind every day. But let's dive into it because, without our moon, that could be our reality. You see, our planet doesn't stand straight up and down. It's tilted. This tilt, otherwise known as axial tilt, is the reason we have seasons. Now picture a spinning top. As it spins, it stays pretty stable, right? But if you've ever played with one, you know that as it slows down, it starts to wobble. That's because of a change in angular momentum, and the same basic principle applies to our Earth. Our planet, in its grand cosmic dance, spins on an axis. But without the gravitational pull of the moon to stabilize it, that spin would start to wobble. This wobble wouldn't be a slight, almost imperceptible variation. No, it could be a dramatic, chaotic shift. We're talking a variation of up to 85 degrees. To give you a perspective, currently our axial tilt varies by just a little over 2 degrees. This extreme wobble would lead to some serious climate changes. We're not just talking about a change in the weather, folks. We're talking about a total upheaval of our seasons as we know them. The areas around the equator could plunge into a new ice age, while the poles might become the new tropics. Imagine, one day you're sipping a pina colada in Hawaii, and the next, you're bundled up in fur, bracing against an icy wind. It sounds like something out of a science fiction movie, doesn't it? But without the moon, it could be our reality. The moon, that luminous orb in our night sky, does more than just light up the darkness. It keeps our world stable, our climates predictable, and our lives as we know them possible. We could be experiencing drastic shifts in seasons, if any at all. So the next time you gaze up at the moon, give it a little nod of thanks. It's doing more for us than we often realize. How would life evolve on a moonless Earth? Now let's dive into the crux of the matter, the potential impact on life forms. The moon, in its silent orbit, has been a silent partner to life on Earth, helping to shape and mold it in ways we are still discovering. Imagine, for instance, the disruption of mating cycles of certain species. Many creatures, from tiny insects to massive sea turtles, rely on lunar cycles for their mating rituals. Without the moon's guiding light, these rituals could be thrown into chaos, leading to drastic changes in population dynamics. And what about those species that rely on the moon for navigation? Birds migrating, whales journeying across oceans, even tiny dung beetles rolling their precious cargo across the African savanna, all use the moon to orient themselves. Without this celestial compass, these creatures could lose their way, with consequences we can only begin to imagine. Then there's the moon's gravitational pull, subtly shaping our planet's environment in ways that have supported the emergence and evolution of life. The moon's pull influences the ebb and flow of tides, crucial for certain species' feeding and breeding habits. It even helps to stabilize our planet's tilt, giving us relatively stable and predictable seasons. Without these factors in place, life on Earth could have evolved very differently. It's even possible that complex life forms, let alone humans, might not have evolved at all. The moon's influence on the evolution of life is profound and far-reaching. It's helped to create the conditions necessary for life as we know it to flourish, from the smallest microorganisms to the vast diversity of plants and animals, and yes, even us humans. So next time you gaze up at the moon, remember it's not just a beautiful sight in the night sky. It's also a vital partner to life on Earth, helping to shape and guide our evolution in ways we are still discovering. Without our moon, life as we know it might not have existed. So, the absence of the moon paints quite a different picture of Earth, doesn't it? Without our lunar companion, Earth would suffer from drastic tidal changes, an accelerated day-night cycle, and a severe wobble that could lead to extreme weather patterns. Life, as we know it, would be significantly different if it could survive at all. Hence, the moon is not just a pretty face in our night sky. The moon, our night's beacon, proves to be more than just a beautiful celestial body. It's a silent guardian, shaping and protecting life on Earth.